All right, welcome back everyone to the deep dive. Today we're diving headfirst into some essential SQL tools, stored procedures, and functions.
These are things that pretty much anyone working with SQL databases is going to encounter, and they can be super helpful for organizing your code and just generally making things more efficient.
And, we're not just going to throw definitions at you. We're going to unpack all of this using the complete SQL Masterclass Unplugged with ARJ as our guide.
Yeah, we'll be pulling out those key takeaways, practical examples, the stuff you actually need to know to start using these tools effectively.
So think of this deep dive as your fast track to understanding these concepts inside and out. We'll cover what they are, how to use them, real-world applications, and even touch on some common interview questions just to get those gears turning.
Because let's face it, constantly writing the same SQL blocks over and over again gets old fast. Plus, it's just asking for errors.
Exactly. So let's start by defining what a stored procedure actually is.
In the simplest terms, it's a pre-compiled group of SQL statements that you can execute as a single unit, kind of like a mini program living right inside your database.
So instead of sending a bunch of individual SQL commands to the server every time you need to do something, you just call this pre-made store procedure, and boom, it handles everything for you.
Right, and that pre-compiled part is important. It means the database has already optimized the code, so it can run much faster than just executing the same SQL statements separately.
I see. So it's like a performance boost too. And I'm guessing they can also take inputs, which would make them more flexible.
Absolutely. You can pass in parameters to customize how the stored procedure behaves.
Okay, and what about outputs? Can a stored procedure return data?
Yeah, a single stored procedure can actually return multiple results and perform actions on the data, like inserting, updating, or deleting records. It's really versatile.
So it's not just about fetching data. It can actually modify the database too.
Yep, exactly. That's one of the big things that sets it apart from a function, which we'll get to in a bit. But think about it this way. If you've got some complex business logic that involves multiple SQL statements, you can encapsulate all of that into a stored procedure.
Okay, so give me an example of how this might actually play out in a real application.
Sure, imagine you're building an e-commerce site. When someone places an order, you probably need to do a bunch of things. Update inventory, create an order record, maybe send a confirmation email, and so on.
Yeah, lots of moving parts.
Right. So instead of having all that code scattered throughout your application, you could bundle it all into a stored procedure called something like process order. Then whenever a new order comes in, you just call that one procedure and it takes care of everything.
Ah, that makes a lot of sense. It's like a nice, neat package for all that logic. And if you ever need to change how orders are processed, you only have to update it in one place.
Exactly. It's all about organization and efficiency.
Okay, now let's talk about functions. Our source material defines these as a reusable block of SQL code as well. But what makes them different from stored procedures?
The key difference is that a function always returns a single value. Think of it like a specialized calculation or transformation that gives you back one specific result.
Okay, so it's like a focused tool designed for a very specific task.
Precisely. And because they return that single value, you can use functions directly within your SQL statements.
So for example, you could embed a function call, write in a select statement to calculate something on the fly.
Exactly. You could have a function called calculated discount that takes a product price and a discount percentage as inputs, and it spits out the discounted price. You could then use that function in a query to display the discounted prices of all your products.
I see, so it's like adding a custom calculation directly into your query.
Yep. They're great for things like calculations, formatting data, or validating inputs. Our source highlights these use cases as places where functions really shine.
So just to recap the main differences. Stored procedures can do multiple things and potentially return multiple values. They're like little programs that you can call on to perform actions.
Right. While functions are more focused, they perform a single calculation or transformation and return a single value, and you typically use them right within your SQL statements.
Perfect. Now, let's get a bit more hands-on. Our source gives some examples of creating and using both of these, which I think would be really helpful to walk through.
Absolutely. So for stored procedures, we have the get employee details example. Create procedure, get employee details, employed int, begin select from employees where ed, employed, end. This is a pretty basic one. It takes an employee ID as input and then selects all the details for that employee from the employees table.
Okay, so it's basically fetching a whole row of data based on the ID. And how would you actually execute this stored procedure?
You'd use the call command, followed by the procedure's name and the input values in parentheses. So to get details for employee number 1, you'd write call getEmployeeDetails.
And that would run the procedure and give you back all the data for that employee.
Exactly. Now, one of the things that makes stored procedures really powerful is their ability to work with parameters, like the employee ID in our example. And the source material breaks down three different types of parameters: in, OUT, and INOT.
Ah, parameters. These always seem to trip people up. Can you explain how they work with stored procedures?
Sure, an in parameter is just like a regular input. You pass a value into the stored procedure, and it uses that value to do its thing. The employed, in our example, is an in parameter.
Okay, that's pretty straightforward. What about OUT parameters?
OUT parameters are used when you need the stored procedure to send back a value after it is executed. It's like the procedure does its work and then says, hey, here's a result for you.
So it's like a way for the procedure to communicate back to whatever called it.
Exactly. You might use an OUT parameter to return a status code indicating whether the procedure was successful or to send back some calculated value.
Okay, I'm following. And then there's INOT, which I'm guessing combines both of those.
You got it. An IOUT parameter is like a two-way street. You give it an initial value, the procedure can modify that value, and then it returns the updated value back to you.
Oh, that's interesting. So it's like passing a variable into a function, and the function directly modifies the original variable.
Yeah, that's a good analogy.
To make this clearer, could we go through some concrete examples from our source? I think seeing how these different parameter types are used would be really helpful.
Definitely. So to illustrate an in parameter, let's look at the update employee salary procedure from the material. Create procedure update employee salary in employed INTT in new salary decimal. Begin update employees set salary where employed is employed end.
Okay, so this one takes two in parameters.
Yeah,
The ID of the employee and the new salary you want to set.
right. And then inside the procedure, it uses those parameters in an update statement to modify the employee's salary in the database. You call this procedure like this. Call update employee salary, 1, 60,000, to, for example, update employee number 1 salary to $60,000.
Got it. So the in parameters are providing the necessary data for the procedure to do its job.
Exactly. Now, for an example of an out parameter, we have get employee name. Create procedure, get employee name, in employee int, out employee name, virch 100, begin select name into employee name from employees, where id, employed, end.
Okay, so here we're passing in the employed, and the procedure is going to find the name associated with that ID and put it into the employee name parameter, which is a text string that can hold up to 100 characters.
Right. And when you call this procedure, you'd need a way to capture that output. Our source material shows this. Call get employee name, 1 at name, select at name.
So we're calling the procedure with the employee ID and this variable called at name. Then the procedure puts the employee's name into that variable, and we use a separate select statement to actually see what's stored in it.
Yep, that's how you'd work with an OUT parameter.
All right, that makes sense. So we've seen how stored procedures can be incredibly versatile, accepting inputs, performing actions, and even returning values.
Now let's shift gears back to functions.
We touched on the get employee salary example earlier. Can you remind us what that one looks like?
Sure, here it is again. Create function. Get employee salary, employed int, returns decimal, declare salary decimal, select salary into salary from employees where it's till employed, return salary, end.
And the key here is that it returns decimal, meaning its whole purpose is to give you back a single numeric value, in this case, the employee's salary.
Right, and the real power of functions comes from how you can use them directly in your SQL queries. Our source material gives this example. Select name, get employee salary, as salary from employees.
So for each employee, we're getting their name and then calling the get employee salary function with their ID to display their salary right there in the result.
It's almost like adding a custom calculated column to your results.
I see, that's really neat. And just like stored procedures, functions can also take parameters to make them more dynamic.
Absolutely. Let's look at another example from the source. Create function, calculate, bonus, salary decimal, bonus percentage decimal. Returns decimal, begin, return salary, bonus percentage 100, end.
So this one calculates a bonus amount based on a given salary and bonus percentage.
Yep. And you could use it in a query like this. Select name, salary, calculate, bonus salary 10, A as bonus from employees. This would show you each employee's name, their salary, and then the calculated bonus amount, assuming a 10% bonus rate.
Okay, so we're essentially applying that bonus calculation to every employee's salary in the table.
Exactly. Functions give you a really flexible way to perform calculations and manipulations right within your queries.
It's like having a custom toolkit of functions that you can just plug and play as needed.
And speaking of toolkits, there's a special kind of function that our source material talks about, table-valued functions.
So far, we've only seen scalar functions, which return a single value.
Right. But as the name suggests, a table-valued function can actually return an entire table as its result.
Wow, so instead of just getting one number or one piece of text back, you get a whole set of data.
Exactly. It's like the function is creating a dynamic table based on its inputs.
Okay, I'm intrigued. Can we see an example?
Of course. Here's one from the source. Create function. Get top employees, N in T. Returns table. Begin return. Select from employees order by salary desk limit N. And this function takes an integer, N, and returns a table containing the top N employees based on their salary, sorted from highest to lowest.
So you could use this to easily get, say, the top 5 highest paid employees.
Precisely. You'd query it almost like a regular table. Select from Get Top Employees 5.
That's really powerful. It's like creating a mini report directly within your database.
And because it's a function, you can reuse it in different queries,
Yep.
and even pass in different values for N to get different results.
So to sum up functions, they're all about making your SQL queries more powerful and expressive. They let you perform calculations, transformations, and even get back entire data sets all within your queries.
Let's shift gears again and connect these concepts to a real-world scenario. Our source uses the example of managing an online store database.
Okay, this is where I think it all starts to click. So imagine you're building the back end for an e-commerce site. You'll need ways to handle things like placing orders and calculating discounts.
Right, and this is where stored procedures and functions can really shine. The source material gives a great example of a stored procedure called place order. Create procedure place order. In customer INT, in producted INT, in quantity ITT. Begin declare total price decimal. Select price quantity into total price from products where id producted. Insert into orders. Customer producted quantity total price. Values. Customer producted quantity total price. End.
Okay, let's break this down. It takes the customer's ID, the product ID, and the quantity as inputs.
Then it looks at the price of the product, calculates the total price by multiplying the price and quantity, and finally inserts a new order into the orders table.
So it's basically handling the entire order creation process in one go.
Yep, and all you have to do is call this one stored procedure with the right inputs. It's way more efficient than writing all those SQL statements separately every time someone places an order.
It's much cleaner and easier to manage too. And if you ever need to change how orders are processed, you just update this one procedure.
Exactly. Now, let's look at how a function might come into play. For calculating discounts, the source material provides this function. Create function, calculate a discount, total price decimal, discount percentage decimal, returns decimal, begin return, total price discount percentage 100, end. Pretty straightforward. It takes the total price and the discount percentage and returns the calculated discount amount.
Okay, so you could use this function to display discounts on product pages or in shopping carts.
Exactly. You could even use it in a query to generate a report of all orders with their discounted prices. For example, select ordered, total price, calculated discount, total price 10 as discount from orders.
So this would show you the order ID, the original total price, and then a new column called discount with the 10% discount applied to each order.
Right. It's a simple example, but it shows how easily you can integrate functions into your queries to perform these kinds of calculations on the fly.
All right, that's a great real-world illustration of how these concepts can be applied.
Now, to wrap things up and really solidify your understanding, let's go through some common interview questions that our source material highlights.
Perfect. I think this will help tie everything together.
All right, first up, what is a stored procedure and how does it work?
Well, we've covered that pretty extensively already. It's a precompiled set of SQL statements that can be executed as a single unit. They can accept inputs, perform actions on the database, and return multiple values.
Right. Next question. What is the difference between a stored procedure and a function?
The key difference is that a stored procedure is more action-oriented. It can perform multiple tasks and doesn't necessarily have to return a value. A function, on the other hand, is designed to return a single value and is typically used within a SQL statement.
Good. Now, how do you create and call a stored procedure?
To create a stored procedure, you use the create procedure statement followed by the procedure name, parameters, and the SQL code you want to execute. Then you call it using the call command with the procedure name and any inputs you need to provide.
Like our earlier get employee details example.
Yeah.
Create procedure, get employee details in employed NT, begin select from employees where id employed, end, and then to call it call get employee details.
Exactly. Now, for functions, how do you create and use a function in a query?
You create a function using the create function statement, specifying the return type and any input parameters. Then to use it, you simply call the function by name within your SQL statement, passing in any required arguments.
Like our get employee salary example.
Mm-hmm.
Create function, get employee salary, employed in T, returns decimal, begin declare salary decimal, select salary into salary from employees where ed employed, return salary end, and then you'd use it like this. Select name, get employee salary as salary from employees.
Perfect. Moving on. What are the advantages of using stored procedures?
Well, there are a lot. They're reusable, so you can write them once and call them multiple times. They can improve performance because the database server can optimize them ahead of time. And they can help you organize your SQL code by encapsulating complex logic into these neat little packages.
And what about the advantages of functions?
They can simplify your SQL queries by handling complex calculations or data transformations, making your code easier to read and maintain.
Okay, a couple more quick ones. Can a stored procedure return a value?
Yes, it can, using OUT parameters. Remember the get employee name example where we retrieve the employee name through an OUT parameter?
Can a function modify data in the database?
Generally, no. Functions are typically designed to be read-only, so they can't directly modify data. This helps ensure predictability and prevent accidental side effects when you're using them in queries.
Good point. Now, what's the difference between a scalar function and a table-valued function?
A scalar function, like all the ones we've seen so far, returns a single value. A table-valued function, on the other hand, returns an entire table, like our getTopEmployees example.
Two more. How would you handle errors within a stored procedure?
The source mentions declare continue handler as a way to gracefully manage errors.
And just to recap, what are the purposes of in, out t, and iout parameters?
In parameters are used to pass data into a stored procedure. AUT parameters are used to get a value back from the procedure after it executes. And IOUT parameters can do both. You pass in an initial value, the procedure can modify it, and then it sends back the updated value.
Perfect. Last one. How do you drop or remove a stored procedure or a function from the database?
You use the drop procedure statement for stored procedures and the drop function statement for functions.
Okay, that covers the interview questions. Let's move on to the scenario-based question.
These are always a good test of how well you understand a topic.
All right, first scenario. How would you create a stored procedure to update an employee's salary given their ID and the new salary amount?
We actually already saw an example of this earlier, but just to reiterate, create procedure update employee salary in employed INT in new salary decimal. Begin update employees, set salary new salary where edited employed end.
Exactly. And next scenario. How would you create a function to calculate the total price of an order given the quantity and the price per item?
That would be something like this. Create function, calculate total price, quantity INT, price decimal, returns decimal, begin returned quantity price, end.
Great. So there you have it, a deep dive into stored procedures and functions in SQL. Hopefully you've gained a solid understanding of what they are, how they work, and how you can use them to make your SQL code more efficient, organized, and powerful.
Absolutely. These tools are essential for anyone working with SQL databases, and they can really streamline your workflow and help you build more robust applications.
And remember, we just scratched the surface here. There's a whole world of advanced techniques and applications out there waiting to be explored.
And speaking of exploration, next time on the deep dive, we'll be tackling triggers and events in SQL.
We'll delve into how these mechanisms can automate actions in your database, responding to events and data changes in real time.
It's going to be a fascinating look at how to make your databases even more dynamic and intelligent.
So make sure to tune in for that. And in the meantime, if you have any questions about anything we've discussed today, or if there are other SQL topics you'd like us to explore, please don't hesitate to reach out.
You can find us on your email or social media handle.
And most importantly, remember to put this knowledge into practice. Think about what tasks you can simplify or automate using stored procedures and functions.
Because once you start using these tools, you'll wonder how you ever lived without them.
See you next time on The Deep Dive.